Dr. Tom Jones, former NASA astronaut, joins us. He's the author of Skywalking and co-author of Planetology, Unlocking the Secrets of the Solar System. Tom, thanks for being with us today. We appreciate it.
Yeah, you're welcome, Brian. Good morning.
All right, so talk about what happened. It was February 15th, 2013, over Russia.
Right, that was over the city of Chelyabinsk in the Ural Mountains, and about 9 o'clock in the morning, a large asteroid, large by our human standards, came streaking into the atmosphere. It was about 50 feet across, came in at 40,000 miles an hour, and when it detonated about 18 kilometers up in the atmosphere, it released about half a megaton of explosive power. That's much, much bigger, about 30 times bigger than the Hiroshima explosion and Nagasaki explosion back in World War II. So that blast wave, as you remember, made it all the way to the ground, knocked out windows and doors, and sent over 1,000 people to the hospital. And the analysis afterwards says that small asteroids like that, which are screened out by the atmosphere, might strike us about every 20 to 40 years, and if it comes down in an urbanized area, you can have some blast damage from that.
Do we do enough research to know about the threat to asteroids? Because we didn't see that one coming.
No, that was completely unseen. It was a small asteroid, and asteroids are usually small, and they're usually dark because of the minerals they're made of, and they're just tough to see. This one, in fact, came from the sunny side of the Earth, and so, of course, our ground-based telescopes can't look in that direction. And so it was a surprise. NASA has a search program, about $40 million a year, to look for asteroids of a large size that can have global impacts, and they're starting to increase the sensitivity of that network. Part of it is the hazard detection that we've just been talking about. Part of it is to find new exploration targets so that we might send robots and eventually astronauts out to visit one.
But do we spend enough in knowing about asteroids, given the fact that, asteroids have, I think what we always say, the asteroids wiped out the dinosaurs. I don't know if that's accurate or not, but we have had planetary changes that have occurred as a result of asteroid strikes in the past.
Sure. The big picture is the Earth's biological history has been altered many times by asteroid impacts. It's a cosmic process that started when the planet formed, and it's still going on today, and we just happen to be aware of it at the time when we have technology now that can help us deflect or nudge a rogue asteroid off course. So whether or not we should be spending more, I think my answer is a little bit more. This is cheap insurance by space program standards. I was on a panel in 2010 that recommended that NASA think about looking for the smaller asteroids that are more numerous and the ones that we've been talking about crashing into us in these infrasound detections. By finding the smaller ones, we'll have a better idea of the hazard that's facing us, the frequency with which they strike the Earth. And because we've only been looking for a little while and because we haven't found too many small ones, we really don't have an idea of the exact frequency. The estimates for a city-leveling blast, the last big one was in Tunguska, Siberia in 1908. About every few centuries, maybe every 500 years or so, we're struck by one of those. But the number could vary by a factor of several. So we need to, I think, not only use our ground-based telescopes, but the next step is a space-based sensor, a small space-based telescope that can really fill out our catalog.
So I was going to ask you about the Tunguska event because that was, like as you said, June 30th, 1908, over in Siberia. Not a whole lot of people there, except for, I guess people who were, enemies of the Tsar at the time. But that sort of pointed to as the impact event that is pretty relatively recent and something that we should be concerned about. Apparently it knocked over 80 million trees over an area of 2,100 square kilometers. I mean, it's a huge shockwave this thing caused. It happened 100 years ago. Realistically, how likely is it that something like that would happen again within the next 100 years?
Okay, well, I just mentioned it's about every 500 years is the current estimate for an object that size.
So we're not due again for another 400 years. We're good.
That's not the way statistics work. It could happen tomorrow. And the fact is that the Tunguska object was about 40 yards across. So we think there are about 1 million objects in the inner solar system, near-Earth asteroids, that could cause a Tunguska-sized explosion. So space is very big. The Earth is relatively small, so we don't get hit that often every few centuries. But in our experience, we don't really know of an event like this occurring in anybody's lifetime. In 1908, there were very few people left around, and there was nobody from Tunguska
certainly not about it. Now it's a huge tourist place, of course, as we all know. Tunguska is on everybody's bucket list.
Larry, we would be wise to increase our detection efforts NASA's got $40 million now. I think buying a space telescope is cheaper than sending a mission to Mars. And so over the next 10 years, it would be, in my view, wise to mount up an internationally funded mission like that to complete this telescopic survey.
And I get that. And our guest is Dr. Jones, former NASA astronaut. And you're proposing we just need to map this out. We need to know when it's coming. Here's my question. Once we know it's coming, then what? I mean, is there anything that can actually be done to prevent this, or is it just a question of, well, when the end is coming, let's at least be aware that it's coming?
Okay, well, if you have a good catalog and you can predict 10 or 20 years in advance what's coming, with our space technology, we can actually do something to change the velocity ever so slightly so this object misses its appointment with Earth 10 years down the road. And that's not hard to do. The Earth is only 8,000 miles across, so if you just arrive a little bit early or a little bit late, you're going to miss the Earth, and we can do that with the technology. One technique would be to slam an asteroid with a small spacecraft, a few tons, going at hypervelocity, 40,000, 25,000 miles an hour, and that transfer of momentum on the impact will change the asteroid's velocity. Another gentler method would be to simply hover over one end of the asteroid for months or a year, and that slight gravitational tug can actually nudge or change the velocity of a small asteroid. So there are several techniques, even lasers have been discussed to ablate and jet an asteroid off course.
We could have a giant laser stationed on the moon.
All right, so if it were up to Tom Jones, former NASA astronaut and all-around good guy, where would you spend the money? Would you spend it first on the asteroid project, or would you continue the mission to Mars?
Okay, well, I was on a NASA panel. I co-chaired that with Rusty Schweickart, an Apollo astronaut. In 2010, we advised NASA that they should spend about 1/60th of their budget to mount this infrared space-based telescope survey. 1/60th of the budget. It would go on for about 10 years. We'd fill up the catalog, then have good warning, and then we could look at an internationally funded demonstration mission. There are several other space agencies, Europeans, the Russians even, Japanese certainly, want to do a demo on a harmless asteroid to show that we've got a plan on the books that will work. And that would be the next step. Using the catalog, we would actually, within the next 10 years, I hope, do this demo mission. Again, that's a relatively cheap space undertaking compared to the amount that we spend every year.
And yet, Charles Bolden, the NASA administrator, just said yesterday, that humanity's future depends on a mission to Mars, Dr. Jones.
Well, eventually we have to become a multi-planet species, or we will go extinct from some cause, an asteroid or something else. I think in the near term we can afford both, to plan for Mars and to do some asteroid insurance. You know, it's the NASA's technology that can help us out here, but to be fair to NASA, you know, the White House is the one that sets the budgets, and so far they haven't prioritized planetary defense as a major spending item.
Planetary defense. What a great concept.
Great stuff. All right, thanks for that.
All right, Tom Jones, former NASA astronaut, we appreciate it. Thank you very much for joining us.